Sam the scientist is tracking turtles that are colonizing the islands of the Florida Keys. Right now, he is studying a mysterious island called Quizzical Island. This year, let's call it Turtle Year 0. There are no turtles on the island. But he returns in 1 year and discovers exactly 1 turtle. In 2 years, there are 4, and in 3, there are 9. Sam collects data for 5 years. He calls the year X and the number of turtles Y. Can you see any patterns? The number of turtles is the square of the year. 0 squared is 0. 1 squared is 1. 2 squared is 4, and so on. So how many turtles would we have after 10 years? 10 squared is 100 turtles. That's a lot. Now, let's write an expression for the number of turtles after x years. X squared. Y equals x squared is a quadratic function. Y is the number of turtles after x years. We initially recognize a quadratic function by the x squared term. More generally, a quadratic can always be written in the form y equals ax squared plus bx plus c. In this case, a is 1, b is 0, and c is 0, but in general, a, b, and c can be any real number, and we've still got a quadratic. Here are 2 more examples of quadratics. From the data in our table, we can make a graph. The graph shows us that the turtles increase at a faster and faster rate as time passes. Let's compute y values for some negative x values. For an x of -1, -1 squared is +1. For an x of -2, -2 squared is +4, and so on. This gives us a symmetrical graph, with a lowest point at 0, 0. This point is called the vertex. Depending on the quadratic, the vertex can be in different locations. Quadratic functions can be represented with tables, equations, and graphs. We recognize this as a quadratic function because it fits the form y equals ax squared plus bx plus c. We can see the vertex here and here. We can also see that the graph is symmetrical. A quadratic function is great for modeling the growth of turtles on Quizzical Island starting at year 0. Quadratic functions model scenarios with constant acceleration.